My name is Taufer. I'm an associate professor at the University of Delaware, and I'm a researcher in high-performance computing. Scientific computing is a very important field of research because it creates opportunities for interdisciplinary research between computer scientists and scientists. And the aspect that is particularly exciting is the fact that through scientific computing tools, software, and data, we can help colleagues in science to discover important aspects of their research and help the humanity. There are several areas in scientific computing that are relevant for the community. Some of them are more interesting than others for me. I am particularly excited to study aspects of molecular structures, dynamics, and understand how this knowledge through computer simulation can be integrated into the discovery of new drugs or addressing and supporting discovering of cure for diseases. I think that that can have a huge impact beyond my research and my group at the level of the humanity. There are several tools that I look with interest, tools that enable scientists and computer scientists to work together for the sake of efficient and accurate simulations. And so we are looking at tools that allow us to reach out to resources that are otherwise idle. I'm speaking about aspects like volunteer computing, where we can go out and reach out to the public to have support for scientific discovery. And one of the tools that is very well known is Boeing. There are other tools that are quite common. They don't reach out to the entire population, but to university and domain, like Condor, for example. These are all tools that indeed create engagement of the public and the community, the scientific community, to work together and create cyber infrastructure that can promote science. As a computational scientist with a passion for high-performance computing, I face challenges every day at the level of integration of applications and computing. So there are aspects of reproducibility, replicability that are particularly challenging and that we are discovering with the increase in concurrency in our supercomputers, in our high-end clusters. And so one of the challenges that I faced in the past and led me quite engage in the aspect of studying replicability, reproducibility of scientific simulation was a case in which we were running a constant energy molecular dynamics simulation. And when we ran our simulation and we look at the data, we discovered that our constant energy was not constant. And that was quite a challenge because I still remember the face of my collaborator in computational chemistry who looked at the results and he just had quite an expression that I cannot forget. In any case, that was inspirational because I understood the importance of understanding not just the tool and the code, but also the science that our tools and code can produce. As we are moving towards exascale computing, we are seeing that computing power is becoming cheaper and cheaper, meant as that we can easily access very large cluster. But at the same time, we see that the more we compute, the more data we produce. And so now we are moving from a compute-intensive problem to a data-intensive problem. These machines are becoming more and more efficient, more and more data are generated, and this data end up on a storage system. And that is the next challenge because we need to help scientists to reach out at runtime to this data and decrypt and capture the scientific information in this data as we are generating them. We cannot afford to save this data on a disk and then eventually when we have the time to look back at this data. So the next challenge for the next 10 years, I think, will be how to integrate data analytics in our high-performance computing system. when a student approach me and ask me, what kind of advice do you give me if I want to work in high performance computing and computational sciences? I think that the first is be open-minded. Don't get discouraged by the fact that you will be working with scientists, and not just scientists in one single field, but many fields. So be open to a different language, be patient, try to learn the different point of view of the scientist, and look at that also from a point of view of algorithm and algorithmically, so that will become easier for you to help, support, develop new tools, and facilitate new discovering. So be brave, be open-minded, learn to work with scientists.